So once again, my name is Šimon. I'm the iOS team's tech lead at kiwi.com. And today I'm going to talk a bit about navigation in iOS apps. I have no idea how long this is going to take, but I don't think we'll need that long. So when we first started developing the iOS app, that was, I don't know, 3-4 years ago, I believe. Yeah. And it was a very simple app back then. I think it only did like native search, and the rest was basically web views. So there was nothing much to navigate around in. And we also used the default Apple architecture pattern, which is model view controller, which looks like this. I mean, you're iOS developers mostly, so I guess you know this stuff, but just in case. The model should be just data, the view should represent the user interface, and the controller is the glue in between. And the way this is presented here, this I suppose the ideal case, but it doesn't really work. Or in ideal circumstances it does, but very quickly it can spiral out of control. So I have like a small example here of controller, all code in Swift. Sorry, I fished that. Just a very simple controller for displaying some search results, which just sets up a collection view and registers a cell or something. And the most, I don't know, the most natural thing to do if I want to use the collection view now is just to conform to the data source. And where do you do that? Well, in the controller, like, of course. Why would you create another file when you can do it right here? And so you just implement the methods, do some configuration of the cell that would fit on the slide. And perhaps you also want to do something once the user taps on a cell in the collection view. So you implement a delegate. And yeah, you size the cell, and when the result is selected, you just push some sort of detail on the navigation controller. And then somebody decides that they would like to order these results based on how close they are to you. So you create a location manager, and here, and you of course make yourself the delegate, and then you implement more delegate methods, everything in the single file, and you can like when you get the location, you reload the search results, and when you get an error, you show it to the user. So I think that's at least it's how we started. I think a lot of people do it this way, and well, sort of. It was an Objective-C. The result of this is that instead of the model view controller, you get massive view controller. Like, I think since you can Google this term and it exists and people write articles about it, it's safe to say that it happens. And the reasons for that are, there are multiple of them. Like, first of all, the name view controller, or the view controller, it's just very vague. You can justify putting anything else in there. In Apple's sample code, in their presentations at WWDC, they also just put things in the controller because they want to make a simple point. Also, if you use storyboards, then you would know that you collect controllers using segues, and therefore the controllers are supposed to be used to transition between different screens. And finally, at this point there, I'm guilty of this as well, but since the other two parts of this chart are so well defined, like, it's the UI and it's the data, so where do you put anything else when you've got 3 possible categories? So of course you put it here. I'm not going to talk today about solving massive view controller. That's like a series of lectures or whatever. I'm just going to focus on one thing, and that's removing app navigation from all this mess. You saw it before where the detail is pushed from the search results, and also when the alert is shown to the user. That's all done in the controller. And I think that one of the fundamental problems in this architecture is that controllers push other controllers. So that's what I'd like to solve. This leads to a thing that, well, first of all, yes, when you have a small app, it doesn't matter because you use each screen once. The flow is defined. You don't need to configure it or anything. It just works fine. But then it happens that you need to use a controller from two different places, or the controller needs to decide something and adjust the flow based on some other conditions. Like, for example, if you have a feature that requires the user to be logged in, and so let's say you want to save some data in our app, for example, that could be or is a search configuration that you can then receive notifications when I don't know, flight price dropped, so that you can finally afford it. So if you have a view controller and you have like a save button there, then the controller needs to then decide whether or not the user is logged in, and if they are, they can just save that information. But if not, a login controller needs to be presented, and only after the login takes place can this flow continue. So this is not ideal because every time we have a feature like that, we would have to, in each controller that it's used in, we would have to instantiate the login controller again, configure it, and perhaps if it has a delegate or something, we need to conform to that too. It would be just nice to have these things isolated, like, you know, something that I think we need to introduce another another component into the architecture. And if you read any blog posts at all online, you know where I'm going with this, right? And this concept is called coordinators. If you take anything from this presentation, just check out controllers, because I think they're a great concept. And what a controller is as the author of the blog post that I founded put it, is a coordinator is an object that bosses one or more view controllers around. It's just it's a higher level object that encapsulates some flow. So saving that information from before, that could be a flow that contains several view controllers. Or the login process itself could be another flow. So what a controller, I think, in its simplest form is just a protocol with two methods, and this can be adopted by pretty much anything, and, well, any class. And it just, given a controller to start from, it presents itself, or it presents its controllers, and then once it's done, somebody can call finish on it, and all the UI that it presented goes away. In the original blog post, the author suggests having a hierarchy of controllers, or coordinators, with an app coordinator and then child coordinators that themselves can have child coordinators. That's one way to do it. We also have an app coordinator, but for reasons that I might go into later, we don't do this hierarchy. We have another object called router, which if you use something like Viper, might mean different things, but I don't. So for me, wrapper is just an object that stores these coordinators so they don't get deallocated. And the only thing that it should do is choose the appropriate view controller that is currently presented, from which more UI can be shown. So I don't know, if you're like on an iPad and you have a popover, you perhaps don't want to present something from there, but from the controller that's behind it. And with these two components, we can shorten the presentation to something like this. Of the login, at least. I can just instantiate a login coordinator, and I can have the root to present it because it knows from somewhere that which controller to use. And the login coordinator, as I said before, can encapsulate more things. For example, here it could be the login itself, but if the user doesn't have an account, it could also have the registration as part of it. And if the user can't log in because they forgot their password, we can have the password set there as well. But coordinators are good for segregating controllers into different parts of, for basically isolating them, because the coordinator represents all the controllers and they don't know anything about other controllers around them. Usually we do it using delegates, that the coordinator is the delegate of all these controllers, and whenever some button is tapped or something, the coordinator receives the message and decides what to present or what not to present. But as I said, this is a very simple example. Usually you need to configure this object somewhat. And for the login coordinator, that could be just if registration is even allowed at that point, or if you're trying to access a feature, then perhaps tell the user why they need to log in. And if your app is simple, again, this is fine. But for our current app, which guys from QA did a graph for not very long ago, our app is a bit more complicated than that. So these presentations add up. And that's something that we'd like to fix. So the idea was to, instead of instantiating coordinators everywhere, to just have some sort of shortcut for doing this. And we call this, well, no, not yet. We need some type for doing this, so these are the choices. I mean, I suppose it could be a function, but that would be not extendable. And so I looked at this and I thought, the app has a limited number of things that the user can do. So they are well defined, there is no other case, and all cases should be handled. And I thought to myself, case. That sounds like an enum. So we made an enum that simply could describe all the things that could be done in the app. And then we used the fact that in Swift you can have properties on, or at least computed properties on enums. So we just have a property to return the coordinator. And then we can just adjust router to take an action instead of a coordinator. So after that, the presentation just is a one-liner, which again worked for a while. But then we realized that, or I realized at least, that you do need to configure these objects. So before I showed you like those two lines where the coordinator had the explanation field and if registration was allowed, we needed to put that somewhere in here. So I guess we'll use associated values on these enums. And then the presentation is kind of looking a bit longer than before, but it's still kind of clear, so yeah, sure. But then you start to realize that you need more things to happen with these actions. And one of these things, for example, is a way to serialize them so that they can be presented from, I don't know, a deep link or a system search or a push notification or something. So deep links are just URLs. So and we can add another extension to the enum, and we can implement the property in the initializer. And sure, I mean, we can like construct something, and then the scheme will always be the same, and the path will be different based on what we're doing. So like, we can do the switch over the cases and get the path. And in case of login, we had some parameters, so we can, I guess, switch on that as well. But nah, just at a certain point, you get too many switches on self. I mean, this is just an example with like 4 different cases. And at last count, when we use the system in our app, we had something like this. So you can imagine that, and one switch over all this needs to be at least this long, and that's just too long for linting, for some R-cube, will tell you that you have too high cyclomatic complexity or whatever, and so yeah, this is not really scalable. Although in our office, I've seen some of our colleagues get around this like just by tilting their monitor. But yeah, I don't think this is the way forward, or at least it wasn't for us, not anymore. So the enum certainly had its uses. It was nice to be able to see everything that the app can do on one screen. But what we couldn't do, for example, was just have properties for only some cases. And if I go back here, I don't think, for example, that it makes sense to have like a deep link to the right app dialog. Why would you do that? So you could get around that by doing like an optional URL of the deep link property, but then you have optionals in code where you know that there won't be any optionals, or shouldn't be at least, and it just didn't fit. So went back here, and grudgingly, because I love enums, just had to give up and try something else. So finally, we settled on a protocol, because, you know, Swift. And the protocol is actually very simple. The only thing that it does is what the enum did before, but it's a formal requirement now that each action needs to return a coordinator. And this is much more flexible, because mainly because each of the navigation actions is now its own type, and we can separate them. Like, it doesn't have to be one enum. We can have an action for login, an action for showing my bookings, and we can also very easily add properties for configurations. Since this is a struct, the initializer will be generated automatically. And one more thing that we couldn't do before, or would be very painful to do or emulate with enums, was default arguments. For example, when we had there was the explanation for the login. Most of the time, there is no explanation, because user clicked the login button. But only in certain cases, we would need to show them why they needed to log in. But Swift enums don't support default values in arguments, so we would need to we need to emulate that by using a different case for the enum, but you saw we had 19 of them, and we didn't even use this approach, so the switches would get even longer. But doing it with the protocol means that we can put default values here. So the call side looks nice again. And another thing that we can do is have presets. I'm not sure if there's a better word for it. Let's say we have a web view because it's useful for certain things like showing FAQs and help files that can be changed dynamically and don't really have any bearing on the app. But if we have an action for that, we can just make a static value that is preset with these properties, and then we can just call it very easily again. But we can also do anything ad hoc that we happen to need. And finally, since I brought up the Deeplinks earlier, we can again do that with a protocol. That only the actions that make sense will adopt. Therefore, we don't need to think of any optionals. And this is just a very simple, this is just a very naive implementation of how that could be done. I'm sure some things could be extracted into default implementations and protocols and things like that. So, well, that didn't take as long as I thought, but longer than I would have liked. Questions?
How does top navigation fit into this?
Right. In the router object that was mentioned like forever ago. Nope. We have instead of having a set of an array of coordinators here, we have 4 different arrays, one for each tab, and this function, of course, needs to cooperate with whatever's currently being shown. And one thing that I didn't show here, but we also implement, we have a system of in navigation actions that each action can have like a preferred tab. So when you open a deep link into My Tickets, for example, you can it automatically switches to that tab, the Manage My Booking tab, instead of being stuck in the tab that it started in.
Did you mention that we should avoid using optionals in our code?
Not that generally, no. I try to avoid optionals when I think, when they don't make sense. I mean, lots of Apple APIs return optionals just because they come from Objective-C and there is no way to avoid it there. But no, I mentioned optionals in cases where you wouldn't, where you would want to do something for some cases, but not for others. So that's just one of the reasons why it's not a great fit for this.
I was just wondering that if there is any best practice how to avoid optionals.
Well, try writing the code without them. If it works, just don't use them. I don't have any deep knowledge about this subject.
And how do you share implementation between, if you want to share the implementation between coordinators, how do you share them? I'm
not sure you can. I mean, what would you share?
I don't know, for example, if you have a coordinator that manages Deeplinks in the same way, you can share the implementation and then implement just the differences or something like that.
No, I don't. Deeplinks are resolved before you even get to the coordinator. I mean, you get the URL, you create an action from it, and the action already knows which coordinator to call. I'm not sure that applies.
Okay, bad example, but I think that some part of logic could be shared theoretically.
Sure, well, we can subclass, I suppose. Or you could.
Yeah, if you do subclassing, then it's fine. But for the presentation, I thought that your hierarchy of coordinators is flat.
Yes, in use you can implement them any way you like. But I just meant that. Well, you might remember this, but this was some time ago when somebody came up with this great idea of having the search screen then going to a save what are they called right now, price alerts, and then you could go from there back to search, but just pushing. And then the requirement was that when you go back, you're not supposed to see the first search screen again. So that's basically why we abandoned the hierarchy, because we needed to just cut something from the array here and not figure out where this coordinator is in the tree. Yeah, it's I'm not opposed to subclassing them, but I don't think we do it. We didn't find origin so far. I mean, since our app is partially in Objective-C, we for our coordinators right now are a class. I mean, flow coordinator is a class and not a protocol, but this is where I'd like it to take it.
In terms of scalability and UI, at what stage would it make sense to switch from a cloud-based hybrid Swift web application to or Objective-C web application to a native Swift Objective-C application?
I'm not sure I know what you mean, because...
So we have a cloud-based application, and we don't have, we have at a certain point we have a native application in our app store, but at some point we are also connected to a web application. So if there are some updates, they are also directly pushed to the native to the application, and we don't need to write all the native parts at an update, for example. But at what stage or at what kind of in terms of performance or scalability, at what point does it make sense to refactor or rewrite kind of web application connected or web app and native app to a native app?
I don't think there is such a point. I mean, it depends on what you use the web-based parts for. But if you need them to be updated, then you can't switch it to native. And the only, the only thing that you would need is to not get lost in the navigation. So, I don't see a reason to do that.
How do you pass around the router? Is it a singleton or do you have?
Right. Right. Yes, it's a singleton currently. But I think part of the reason that's the case is that some of our coordinators are in Objective-C, and we can't use certain techniques that would allow us to do it differently. I mean, we could theoretically have like just an initializer for each coordinator that takes a router, but currently don't do that. I mean, the router also has, since the actions themselves are pure Swift, we need a way for the Objective-C coordinators to call into something different. So the router has special methods for them to that basically wrap the action call. So yeah, for now it's the same. I see that as a deficiency.
I have one question. When it comes to dismissing controllers or going back, is it also part of the like a router flow coordinator scene or the technique you use, or do you prefer to just call it on controllers like a dismiss or?
I try to keep everything in the coordinators. That's I mean, I don't know if it's always possible, because you have things like the edge swipe, when you don't really get a callback for that, or even the back button on the navigation controller you don't really control. But I think currently we work around that by doing by having a delegate from the controller called on view did disappear or something like that, and then checking if the controller is still in the navigation stack or not, and dismissing the coordinator then.
So if I get that right, in the router, there are arrays for each tab,
Yeah.
and that is basically backstack, or all the screens that are stacked
Yes.
on the, and when you go back or finish some screen,
Yeah.
just throw it away.
Mhm.
Yeah. Cool.
So do you think of this as a final step, or do you already see some kind of issues that might arise?
Well, we've been using the system for, I think, like half a year, perhaps, maybe. And there are issues, but I'm not sure how to solve them yet. For example, since it's also protocol-based, I thought we could add like logging to these actions, so that whenever the coordinator that the action contains is presented, you could just like send a log to somewhere. Yes, but that's fine in theory, but then we realized that in multiple situations you need that log to be sent at some later point when parts of or something in the coordinator is loaded, and you can't do that because you don't have the information. So I'm not sure how to solve that yet, and maybe logging should just be kept out of the system altogether.
Does this architecture involve to affect somehow performance, or is it just for sake of readability of the code?
I think it doesn't have a performance impact, certainly. I mean, it's just a few more objects that call methods instead of the controllers calling them themselves. It's, I think, purely for readability and organization. But, the app is kind of big. It has like 120,000 lines of code or something, so readability is important at that point. Okay, so thanks for listening.